Hi there, this is Edmund from Optodyne. My goal for this video is to show how simple it is to perform an CNC ball screw pitch error measurement using the Optodyne laser. I'm new to the industry, and when I ask why more companies are not calibrating their CNC machines, I get these three very common responses. First, I didn't realize that the linear pitch errors can be compensated within the CNC. It is very time-consuming and difficult to perform. We do not have the skills, and it is very expensive. Lastly, we have a system, but it is too complex, not practical, too large, and difficult to transport. It is currently not being used. Here is an illustration of the traditional interferometer laser most folks are familiar with. You have the laser on the tripod, the alignment to an external interferometer, and then another alignment to the target retroreflector. This setup requires a three-point alignment, and it can be extremely difficult to set up due to access and placement of all the interferometer components. This is the Optodyne laser. We are able to shrink the laser to this small size so that it can be mounted within the machine rather than on a tripod. With our patented LDDM technology, we are able to place all the complex external interferometer optics inside the laser head, eliminating the need for interferometer setup and the complex three-point alignment process. I'm going to perform the laser alignment on the x-axis of this machine. I'm going to first place this retroreflector on the spindle. This retroreflector is a corner cube. A corner cube reflects the incident beam of the laser directly back at the same angle, which makes the alignment process very simple. I want to make sure that I place my laser outside the X travel, so I'm going to go ahead and move my X to the 0. Now that my X is 0, I can safely place my laser on the machine tool. I'm going to place this laser perpendicular to the travel of my X. I'm just going to do it by eyesight. So at this point you can see the laser. So now I want to use the jog wheel for my Y and Z axis to move the beam onto this corner cube. So I'm going to go ahead and move it down, move my laser back, move it down some more. Beginning to see the beam there. So at this point, I'm beginning to see the reflected beam from the laser on the face of this laser. And by moving my Y and Z, I can move this beam back into the aperture. Now I'm going to move it out on the x-axis. You see the beams coming out? Now I'm going to make all my adjustment using the steering mirror on the laser. Putting the beam back in. Continue to move X out. Putting the beam back in. Moving X back in. The beam is just slightly out, so I'm going to make my adjustment when it's near using the jog wheel. Not the steering mirror, but the jog wheel. Move the X back out. Just final tweak here. Back in. The beans stay inside the aperture. The alignment process is complete. Now we can move forward with the measurement. I hope this video provided you with the comfortable knowledge that you can perform your own calibration and how the complicated alignment process can be accomplished in a few minutes instead of an hour or more, saving you time and money. Thank you for watching.